Hi, my name's Jayden Ong,
And my name's Ian Limasi.
and our group is called Nodi.
Okay, yeah, so in terms of our motivation, we wanted to solve 4 problems. The first one being notification fatigue, because nowadays we're constantly bombarded by notifications, which can cause constant distractions and also lower productivity. And then when it comes to traditional focus mode tools, they have very rigid configurations because those tools either block all incoming notifications or only allow them from explicitly specified sources. And then during development, we also wanted to use a cloud-hosted LLM to determine whether a notification was unimportant or important. But the problem with that is since it's on the cloud, it introduces risks to compromising the user's security and privacy. And so that's why we built Nodi, which is essentially a notification filtering tool that filters notification contextually using an on-device hosted micro LM to ensure that user security and privacy is protected because notification contents usually contain sensitive information.
And then for our demo, we'd like to ask for everyone's help. I registered this phone with a temporary Google number, so if you guys are willing to help test our capstone, feel free. And we're gonna
Just message you?
yeah, just message me, and then we'll see what happens. But briefly, we can talk about what Nodi looks like. We have, let me just turn it on real quick. All right, there we go. So once I've enabled on Nodi, it turns on a focus mode that helps enable Android Do Not Disturb permissions. Oh dear.
I guess that's important.
But it also, we want to like make sure like urgent information comes through at any given time, but we also want to like filter out spam as well. So we currently have, if we go to blocks, we can see what gets blocked. So like the unimportant stuff and all the unimportant notifications will all show up here for lists. So if we want to see come back at a later date, we can always come back. But in the meantime, we can see all the really important notifications coming through, something like emergencies, time-sensitive notifications, or something that really, really, really needs my information, such as that.
Well, you're going to share.
Maybe. We can get into the limitations in a bit, but as for the sake of time, we can happily go on to the next steps.
Can we see what was blocked?
Yeah, we can go here and we can see what our LLM determines what's important and what's not important. So we can see like,
I mean, it's doing a good job.
that's true. We can see that how I'm not getting as many notifications as like if everyone is spamming me. And yeah, sure, we've got all of these. And then like I have some like test notifications at the bottom here. But every time we open a database, it'll update what we have here. We currently have like, one of our stretch goals was to include a chatbot that could like help customize notification filtering to everyone's preferences, but we can talk about that more in the future. I'm sorry, we can talk about that more later in the presentation, but
Can you go back? Let's actually go to the previous version and let's try to like, I mean, it's really, by the way, I would say it's like amazing that you guys are allowing us to like really break the system. That takes guts. So let's try like a few things. I just said our project is due tonight. When can you work?
so basically, give me 1 second. If we turn it off briefly, we can see that we can display like time-sensitive notifications. Right now it's off, so it's gonna like filter everything. But just so when everyone's like texting me all at once, you can see like how it's all spamming me. What the focus mode would actually do is, if we turn it back on, it puts all the notifications in a queue so that our local model, which is Quen 3, will not be overwhelmed by like the influx of notifications. So everything gets processed like one by one, and then whatever's deemed important will show up in the notification bar, and whatever's blocked would end up here. So now we can Okay, I turned it off, so my phone's gonna
You
get,
turned it off.
yeah, I think my phone's gonna continue buzzing for a while, but
That's awesome.
Wait, so how big is this model?
it's a 0.6 parameter model, billion parameter.
What model is it?
It's a Qwen 3 0.6b.
Did you fine tune it or was this like by itself?
We had to like fine tune it, but we can get into the metrics of what happened.
Why didn't you use 3.5?
3.5.
Yeah, the Quen 3.5.
We wanted to like choose something that was like low latency that could like run on like any wide range of phones. Like this is actually my old phone, so it's like 5 years old. So we wanted to like include like the biggest range of users because not everyone has like a super current phone, and maybe they just want some basic filtering on whatever device that they have.
But what about the Quen 3.5, 800 million parameter model?
We didn't look much into
Okay.
current detail, but we saw that like 0.6, Quen 3 0.6 billion was like the most stable.
Okay.
So if it'll let me.
So essentially, when it comes to the training data set, we use over 200 notification samples, and we try to make it as even as possible, so like 50 to 50 ratio of unimportant and important notifications. And then for testing, we used a data set of a size of 500 sample notifications. And we also try to test some of the edge cases, so notifications that could be ambiguously important, and just things that might cause like a false positive. And when it comes to the models that we use for testing, they're listed on the screen.
And then now we can go into our benchmarks. So we can see here that the base Quen 3 0.6 parameter didn't really perform really good because it could be easily fooled by, for example, like if Uber Eats sends you like this like fire sale or like big promotion, it's gonna like get through and ultimately be an annoyance. So once we trained like Quen 3 using our training data set for 3 epochs, we noticed like a considerable increase in accuracy in like predicting unimportant versus important notifications. And then our baseline call would be our Grok 8 billion model, Llama model, which would be 78%. We didn't want to train that model, just like establish some what a goalpost like big cloud LLM implementation would be. But our final Quen 3 5 epoch tuned model got an accuracy score of 83.2%. And then that plays into what also is important, like which is called latency, which would help determine the importance between a cloud LLM or a local LLM. So what we see here is that all the local models are pretty fast at processing text with like their varying degrees of accuracy. But we can see here that the Llama model, it takes 2 seconds to process a notification, which if I get spammed every day with like endless texts, would not be really fast in processing all my notifications. It'll probably take up a lot more time to process than the local LLM. Because one thing we noticed when testing with Grok is that we get rate limited with the amount of like API calls. So unless we want to pay for a premium plan and get faster and more frequent API calls, we chose a local model that lives directly on our phone for faster processing. And also, we don't want to send our personal notification data to the cloud, and we want to ensure users' privacy with a local model.
This is latency on what platform?
This will be testing latency. We tested latency on this like Mac itself because this M2 Mac uses a mobile architecture, so we figured it's more similar to the same CPU architecture a mobile phone uses. And then that ties into model performance by category. We can see here that Grok performed really well in terms of like ad spoofing with all the fires. Let's say like if Uber Eats sends like a spoofing notification that tries to like trick our LLM, this is something that we can work on. We can work on tuning our local LLM. We can get into our failure case. But one thing we noticed like that was particularly interesting is that since Grok is not a trained LLM, it can easily like filter out all the. We can also like filter out all the spam, system notifications, and random noise. But when we come to like group chats and DMs, it gets a bit more ambiguous. So our approach to giving a trained local model that runs on your phone for processing Android notifications, we can see that it works a lot. It works a lot better when compared to Grok in some cases. And then Quinn's baseline, we've noticed that it was like really inconsistent. So it would either fire important or unimportant. So that's why it seems like it gets everything correct. But then we get to like the other case, like spoofing, and actually the stuff you don't want to get notified, it completely fails at that. So then we get to our actual failure cases. We had an original chatbot that we want to like implement to make sure we can customize filtering for each and every user because different people have different priorities. But during our testing, we always see like this output think during the Quen chatbot. So currently that's not working, and that could be a good stretch goal or a future step. We also noticed, as I said earlier, ambiguous prank spam messages. So let's say if you were to message me like emergency and then the word hi, it would probably get through because it sees the word emergency and thinks it's a really important notification. So we need a better data set and also more tuning just to make sure that would work properly. And also during our testing, we noticed like if someone were to message me like, I need the exams in an hour, and this is a really particular case we had, but if someone were to message me that an exam's in an hour, I need a cheat sheet, that wouldn't get through. But if that message was rephrased or like had more punctuation or a lot more caps, it'd also get through. So that's probably likely an issue from our training data set, which was like synthetically generated using like AI and doesn't really represent like complete like human messages, which have like all caps or accounting for how people differently text. And for next steps, we want to, as I said earlier, that we want to train for ambiguity, which is we have to like get more data samples on like the huge range of Android notifications that we could get. Like some notifications are all caps, some are all lowercase, some use a lot of exclamation marks to try to get my attention. So we want to account for all of those. And our current approach would be to like make sure our notification filter is not too strict. We would prefer if the occasional spam message got through rather than something unimportant being restricted. So that's why we tuned the filter to allow to be not as strict on our filtering, but a bit more careful. And also, we are also looking into like finding different models to integrate for a chatbot to actually get the personalization feature working. So in the beginning, we were using like the Grok Llama 8 billion parameter model to like use as like the chatbot to like send requests over. But ideally, we don't want to send our personal preferences over to the cloud. So we want to keep looking at models that we can implement that could better support the chatbot feature and not bug out as much.
And then for the last next steps, we also wanted to implement a timed focus mode. So once we have the preferences customization set in place, if the user says something like, oh, I want only these types of notifications from 3 to 5 p.m., and then from 6 to 8 p.m., these other types of notifications should be allowed. And so in order to do that, we would use Android's alarm manager and broadcast receiver tools. So yeah.
And that's it. Any questions? Yeah.
Yeah, you said you use synthetic data for your data set. Was it all synthetic data, or was there also data sets that you explored?
It was hard to like find like notification data online during our initial search, so we mostly used synthetic data to like generate our training and test sets. Ideally, the limitation that comes with that is that those would probably be like punctuated or like typed like or had the same general language. So that's like one limitation we could address with different types of training sets.
Yeah, I agree that that's probably where it is. And then like you could have also gotten just like how people talk inside, these kind of environments. I wonder, what other stuff there. It seems really cool. Yeah.
Thanks. I would say maybe in the future we could like send out, maybe we could like have like surveys. So there's not like any pressure for people to like give up their like sensitive information, and then they could like describe like how they would talk, just so for us like model it better and like account for how everyone talks. Yeah.
This reminds me, like, recently there's like Claude, I think their source code got leaked or something, and when they looked at like their filtration code, it was like just standard regex, right? So I was just thinking, like, you mentioned there's a problem of like the queuing, right? If there's a lot of the overwhelming. Did you ever like, if you were to like scale this or like actually make this a service, would you think like having a first layer of defense of like a way more simpler filtration system help?
We did originally try to use like regex a lot to like filter like common spam notifications, and then like if we get like a guaranteed like emergency, like let's say someone types in like I'm at the hospital or like the word hospital, it'll like automatically filter through. But then we would have to like account for more false positive phrases, because let's say someone really needs my attention, and then they say one keyword that's in the spam, their notification won't go through, and vice versa. If someone were to say like emergency, I'm a Nigerian prince and I need money, it's gonna get through. So we want to try to like eliminate as many false positives as possible, while still allowing like the most important information to get through. So it's like a big balancing act. Yeah.
Could notifications include phone calls? Like, can you like weigh like, oh, if there's a phone call plus a text message, then this is probably pretty urgent, something like that?
We could look into that, because notifications on Android phone calls on Android are handled by a different API that bypasses Android's notification API, so it'll be a whole complete different process, but that's probably a good stretch goal too. Yeah.
I guess kind of relatedly, I assume, is the model like purely text only, or does it handle images as well? Because like some spam text that I get will like send me an image.
I think it's mostly text for now, because it's going to be like computationally harder to process locally an image.
Yeah.
Yeah.
So you guys have a couple of versions of the Quen model there, one that's a 3 epochs and one 5 epochs. What did you guys do for those epochs? Did you start fine tuning on the model?
It was just like we continued to let it like fine tune for a longer period of time, just so Quen could like learn our training set better, and then
Were all the parameters unfrozen?
everything other than the epochs were the same.
Okay.
Yeah.
I guess for curiosity, when you're like training your model for like filtering for emergency versus non-emergency, is it based off keywords or is it like a whole message?
We based it off of a whole message to enable like contextually, so like the model could like determine the context of a message to determine whether it's important or not. Because if you filter by keywords, we would run into the same false positive issue again. Yeah.
Did you ever think about adding context, such as the name of the person who owns the phone? Maybe like a message that name drops you, or like if they're a known contact versus just a random number?
That would be a really good stretch goal for our future like chatbot feature, where you can say like, I need any message from my mother or my aunt, I would like those filtered through. So once we get that working, we can like store the user's preference in like inside a string that adds on to the prompt that we use ourselves, so we can account for further personalization.
So last question, like, you said the model ran on the phone during the demo? Which phone was that? Was it like latest iPhone?
This is my like 5-year-old Nokia.
The model was running in real time on that. Yeah, that's good. All right, sounds good.